are going to we have seeds here. So a company is selling vegetable seeds in packets of 20. Estimates that the number of basil seeds that will actually grow has a mean of 15 with a standard deviation of 2. And the number of cilantro seeds that will actually grow has a mean of 14 with a standard deviation of 3. If you buy 1 pack of each, how many seeds will you expect to grow? Okay. How many seeds will you expect to grow? So, and what is the standard deviation? So we need the expected value. First of all, we need to define our variables. So first of all, we need to define our variables a little bit. So we've got, what kind of seeds do we have? We have basil and cilantro seeds, right? So the expected value of basil seeds is what? How many basil seeds do we expect to grow? 15. And the mean, the standard deviation, let's just write the variance. What's the variance of basil seeds? If the standard deviation is 2, what's the variance? 4. Variance is standard deviation squared. Okay? So B is basil seeds that will grow. Okay, so now we have cilantro seeds. So what's the mean, the expected value for cilantro seeds of growing? 14. And the variance of cilantro seeds? 9. By writing the variance right away, it'll make your life easier when you do this. Okay? So now, the expected value of 1 pack of each, that would be the expected value of basil plus cilantro. Yes? Okay. So wouldn't that just be then the expected value of basil plus the expected value of cilantro?
Yes.
Okay. So what's the expected value of basil? 15 plus 14. So you would expect 29 seeds to grow. And this should make perfect sense. If they tell you you expect 15 basil seeds and 14 cilantro seeds to grow, if you buy a pack of each and plant them, doesn't it make sense that you'll have 29 seeds that grow? Does that make sense? Okay. Now the variance, now we need to find the standard deviation. To find the standard deviation, we find the variance using our formula and then square root it to get the standard deviation. It's that simple. Variances always add, even if you're finding a difference. Okay, we'll spend more work, and now the 2 will be a difference. Okay, but let's find the standard deviation, or the variance of basil plus cilantro. That will be the variance of basil plus the variance of cilantro. What was the variance of basil? 4. Plus 9 is 13. And then to find the standard deviation of basil plus cilantro, that's the square root of the variance. So that would be the square root of 13. Which is what? 3.61 seeds.
How did you get 9?
Because it's not a stupid question, because the standard deviation of cilantro seeds was 3, you square it to get the variance. The variance is the standard deviation squared. That's from the previous notes. The variance is the standard deviation squared. So then we would expect a range of 3.61 seeds. All right, so now if you buy 1 pack of each, what is the expected value of the difference in the number of seeds that will grow? What is the standard deviation? Okay, now we're going to practice the difference thing. So now we need the expected value of the difference of basil minus cilantro. So that is the difference of basil, the expected value of basil and cilantro. Expected value you add. If you add the variables, you subtract if you subtract the variables. That's what you do on expected value. So the difference would be 15 minus 14, which would be 1 seed. Wouldn't you expect 1 seed difference if you bought 2 packs and planted them? Yeah, that would be the difference, because basil seeds are supposed to grow 1 more. Okay, now the variance of B minus C is the same as the variance of B plus the variance of C, because that's what the rule says. Where are these rules? What? Yeah, they're on another page, but I'm just showing, they're in your book too. In fact, I like the way the rules are typed in the book. I like using the variance and We're in chapter 16 now. And there's plenty of examples if you look through, like step-by-step examples. It's in the What Have We Learned section that all of these formulas are, right here. The standard deviation is the square root of variance. Okay, we're going to look at these things. Right now we're looking at 373 and 374. Those are our rules that we're using. They're right on the What Have We Learned part of our book. So those are rules that we're using to combine random variables. Okay, so the variance would be, so isn't the variance the same as it was in the last problem then? So it's still 3.61. This is same as above, same as in number 1. Okay, when you combine random variables, adding or subtracting, the variance is always add. Okay, so if you buy 3 packs of basil seeds, how many seeds will you expect to grow? Well, wouldn't it be the expected value of basil plus basil plus basil? So that would be 15 plus 15 plus 15.
Wait, wouldn't that one be 13? Because that would be the standard deviation.
The square root of 13 was...
Yeah, that was...
Oh yes, you're okay. So this would be the square, this would be 13, and then the standard deviation of B minus C would be 3.61. Yeah. It ends up being the same answer in the end, yes. But you're right. I labeled the variance and we wanted the standard deviation, so. Okay, so now if you're buying 3 packs of basil seeds, it's now we're just adding 3 random variables. So basil plus basil plus basil, that's like the expected value of basil plus the expected value of basil. You know, you're buying 3 packs. If each of them is going to grow 15, how many basil seeds? 45. The expected value part should be common sense to you. Does that make it? It should be. If I buy 3 packs of basil seeds and I expect 15 plants to grow in each, I should get 45 plants. Okay, now the variance of basil plus basil plus basil would be the variance of basil plus the variance of basil plus the variance of basil. Well, what's the variance of basil seeds? 4. So 4 plus 4 plus 4 is 12. So the standard deviation of the basil plus basil plus basil is the square root of the variance of basil plus basil plus basil. Well, what was the variance? No, what was the variance? 12. So the square root of 12 is 3.6? 3.46. Okay, now you're going to buy 3 packs of basil and 2 packs of cilantro. How many seeds would you expect to grow? So the expected value of, can you just say like 3 basil plus 2 cilantro? Can you do that? Ooh, you can. But you know what? We need some more rules to do that.
Why?
Because there's other rules. You need to know what to do with constants. Because now we have constant. Now we could just write it basil, 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 cilantro, cilantro. But it's going to be nice to know how to deal with it. Isn't this shorter?
Yeah.
That's a lot shorter. So we need to know how to deal with that. And the rules are on that same page I was just on. So I'm going to write the rules down. It's basically with rules 272 and 273. It tells you what to do. So the rules there, it says, I'll write them on a separate sheet, but you might want to make sure they're there. It says the expected value of A times X is equal to A times the expected value of X. What is that saying? That's saying the expected value of 2 times cilantro would be 2 times the expected value of cilantro. You just have to, if you have 2 of them, you just multiply. Okay, another rule there's one of the rules. Another rule says the variance of A times X is equal to A squared times the variance of X. This is the key one right there. And then they've got a rule 372 too, it's the addition ones. But this is the key rule we're going to have to use here. So, it's on page 382. I'll write it again, I'm sure. Okay, so for this one, it says that the rule says that the expected value of 3b plus 2c is the same as the expected value of 3b plus the expected value of 2c, which is the same as 3 times the expected value of b plus 2 times the expected value of c. Yep. So what is the expected value of b? What is it? No, the expected value of just b. 15 times 3. And the expected value of cilantro? 14 times 2. So 45 plus 28 is what? 73 seeds you would expect to grow if you bought 3 packs of basil and 2 packs of cilantro.
Yes.
All right, so now we're going to find the variance of 3b plus 2c. And this is where we have to use the rule we just wrote, which says the variance, well, that would be the variance of 3b plus the variance of 2c. And here's the rule I just wrote. The variance of ax is equal to a squared variance of x. Okay, that's the key rule. So where's that 3 going to go? Out in front, but what do I have to do with it? Square it. So this is going to be 9 times the variance of b plus 4 times the variance of c. So what was the variance of b? Basil, 4. And the variance of c? 9. So that gives us the square root of, or sorry, just 72. And then the standard deviation of 3b plus 2c is the square root of 72.
Yeah, because if you write it all out the long way,
Yeah. No, this I did write it out you do.
I mean, like, if you do, like, variance of b plus variance of b plus variance of c plus variance of c plus variance of c.
You don't get that.
No. Right. Because then it'd be like 4 plus 4 plus 4 plus 9 plus 9 is 30. Then you take the square root of 30. So it's like less than half. You have to square each of those values.
Yeah.
What?
It's the square root of all those values squared. So it'd be like 16. Is that right? Yeah, 16 plus 16
But
plus
they already
16.
are squared.
They would be 48.
Because the standard deviation were 2 and 3, so they already are squared.
So the variance of, so that would be the variance of b plus the variance of b plus the variance of b, which is what? What's the variance of b? 4?
4.
So that would not be the square root of 72.
Right.
What the heck?
That's what I got.
That's not good. Because
But I
math
didn't know if
is,
they were like using different variables or different things.
Because then when we go back to do number 3, even though it'd be just like 9,
I'll do it.
yeah.
Maybe it's just the a squared times the standard deviation.